Hey everybody, this video lesson is going to take us through calculations involving pH and pOH. We're going to begin with this example of a beaker full of 0.50 molar HCl. Now HCl is a strong acid, and it's assumed that if you have 0.50 molar HCl in the beaker, then you have 0.50 molar H plus ions. But what some people don't think about or don't remember is that this solution has mostly water in it, and water has this ability to create H plus and OH minus. Rewrite water as HOH, and it's pretty easy to see that if you split up water into H plus and OH minus, you have a little bit of acid and a little bit of base that comes from just water. This is what is known as autoionization of water. Auto means automatic, and ionization standing for becoming ions. So water automatically ionizes itself. Now there's a deeper explanation of the autoionization of water, but I'm not ready to get into that with this class. It's something that we can talk about if you decide to take AP Chemistry. But what you need to know is that because there's water in the solution, there's some OH being produced along with the 0.5 molar H+. Now the amount of OH in solution is measurable. It's not large, but it's there. And what this means is that for any solution, whether it be an acid or a base or neutral, there's always going to be some acid, in this case a lot of acid because what we have is acid, and some base due to the autoionization of water. All solutions contain some H plus and some OH minus, and because they do, we can calculate the pH and the pOH for a particular solution. And what's even more interesting, and again I'm not prepared to explain this to you fully, but if you take the pH of a solution and add its pOH, it always equals the whole number 14, which we will be using in the upcoming problems here. So this is one of the formulas that you want to know. So how do we get to pH if we know the H plus concentration? The same question can be asked, how do we get to pOH if we know the OH minus concentration? And it's actually quite a simple calculation. It includes base 10 logarithms. The pH of any given solution is equal to the negative log of the H plus concentration. And the pOH of any given solution is equal to the negative log of the OH minus concentration. Take for example my 0.5 molar HCl once again. If I take the negative log of the concentration, I get the pH, which is equal to 0.30. Now, one thing about pHs is the significant figures rules are a little weird, and I'm not going to go into them with you. So, for significant figure purposes, always round your answer to 2 past the decimal. Another thing to note about pH values is that they have no units. They are a unitless value, it's just a number. Now, since we know the pH is equal to 0.3, and we know that the pOH plus the pH equals 14, we could calculate the pOH by simply subtracting it from 14. And you would get 13.70, and that's the pOH. Simple enough. Now you might be wondering why I didn't use the pOH calculation to calculate the pOH down here. And that's because I had an acid to start. If you have an acid to start, you can use the pH formula to find the pH and subtract from 14. But if you had a base to start, you could calculate the negative log of that base to find the pOH right off the bat. You'll know you're looking at an acid if it starts with an H, and you'll know you're looking at a base if it ends with an OH minus. The identity of the substance will always be given to you in the beginning of the problem. Now what happens if you know the pH or the pOH and you're trying to find the H plus or OH minus concentration, and you just have to work the pH formula in reverse. If pH equals negative log of the H plus, if I solve this for H plus and I use a little calculator magic, then what you get is H plus concentration is equal to 10 to the negative pH power. Remember, the inverse of a log, or log to the negative 1 power, is the same as saying 10 to the x power, where x is the exponent. And so, to calculate H plus concentration, you simply take 10 to the negative pH power. And the same is true for POH. If POH is equal to the negative log of the OH, then 10 to the negative POH power is equal to the concentration of the OH minus. So here's a beaker. And I know the pH inside the beaker is 2.75. And I ask you, what's the concentration of H plus? Well, it's as simple as going 10 to the negative 2.75 power. And the answer is 0.0018 molar. Now, concentrations do have a unit, molarity, but pHs don't. So make sure you label this properly. And as with significant figures, just do 2 significant digits whenever doing calculations involving pH or POH. So here are the formulas you need to know, important formulas, and in fact I did not include the inverse formulas here, so I'm going to write them in. But these first two basically are defining the concept of an acid or base are equal to its H plus and OH minus concentration. Those are just assumed. Now these next three, with the inclusion of 10 to the negative pH power, is equal to the H plus, and 10 to the negative POH power equals OH minus. These 5 formulas will be given to you on the quiz and the test, and you'll just need to know how and when to use them. So pay close attention to these 5 formulas because we're going to use them in the next couple practice problems. So let's diagnose this first one. We've got 0.0001 molar HCl. That's an acid. So if I take the negative log of that number, I get 4.00. That's the pH. Remember, the negative log of an H plus, or the negative log of an acid, is the pH. On the other hand, if I ask you what's the H plus concentration of a solution that's pH of 2.5, I take 10 to the negative 2.50 power, and I get the concentration of 0.0032 molar. Now finally, this last question is referring to bullet point number 2. What's the pOH of this solution? Well, if I know the pH is this, then I do 14 minus the pH to find the pOH, which is 11.50. That's the pOH. Now this last problem is now working with a base. You see it ends in OH, so if I take the negative log of a base, 0.0365, I get the pOH. That answers the first question. What's the pOH? The answer is 1.44. Now this next question also asks for what the pOH is, but it's of an acid, not a base. So this is going to take actually, once again, a series of 2 calculations. First, since I have an acid, I can take the negative log of that acid and find the pH, which is 3.22. And to find the pOH, I'll take 14 minus 3.22 and get 10.78. If you notice, these two numbers, the pH and the pOH, always add together to equal 14. Now these are basic pH and pOH calculations. As you'll notice on some of the worksheet problems, there are some problems that include using molarity, where you first have to calculate the molarity using the moles over liters formula, and then you'd be asked to figure out what the pH or the pOH is. You'd also be expected to know how to use the dilution problem. Maybe an M1V1 equals M2V2, where you solve for M2, and then after you've solved for the M2 upon diluting, you're then asked what's the pH or what's the pOH. You can expect to see a molarity problem or a dilution problem on the quiz or test coming up. It's a combination of concepts from last chapter and this chapter all together in the same problem. Well, that concludes this video lesson. Thanks for listening.